This is part 2 of 3 of Why Don't My Pixels Work? Now, in the previous video, section 1, we've already troubleshot up to the point where our connections are powered through the fuses. We've checked the fuses, we've checked the connector, we've checked the cables, we've checked the pixels, and we have still determined that this beyond here is all okay. We've done that through the A/B swapping process. So now we're going to track from this board up into the CPU what could possibly be the problem. Now, there are two major systems within the HolidayCoro ecosystem, and that is the Evolution system. The Evolution system is based upon a ribbon cable connector, and that applies to whether you have a HinksPix Pro here. This is a version 2. If you have a version 3 CPU, and that has 5 ribbon cable connections, or if you have the AlphaPix Flex Evolution controller, and this has 3 connections just like the version 2 here. Now, we are not going to be talking about the long-range board. The long-range board does have a ribbon cable, and its troubleshooting would normally be different, especially as it relates to smart. So see the videos under HolidayCoro.com/long-range for troubleshooting any kind of long-range device. So we are going to assume that the problem we're troubleshooting is this SPI type board, and this board may be the type with the green plugs, or it may be the type with these poly fuses and push type connectors, or some other different variation. All right, now it's important to understand that we do have a ribbon cable, and so at the bottom down here we have our expansion board, and there's our ribbon cable connector. You'll notice that it has hooks on the edge. These hold the ribbon cable in place. Now, there are cases where this can become dislodged. That is rare, but it does happen. Here's the ribbon cable type we would be using, and you can see that it has multiple connections. First is, if you've built your own controller, a non-HolidayCoro factory-produced controller, you may have connected multiple expansion boards to each of these connectors. That is not possible. There only can be one connection to the CPU and one connection to an expansion board. So even though there are multiple connectors here, these are here simply to be able to cut the length of the cable to fit all the different combinations of stacking. All right, so where do we start? Well, first we make sure that our ribbon cable is fully seated. Now, it's impossible to make it not seat correctly in the sense that it is keyed. You can see a little connector here and a slot right there. So when you push your cable into the SPI board, not only should the pins go up and lock into place, they should now be fully vertical at this point and clipped onto the edge of the ribbon cable IDC connection. If these are in any way dislodged, such as this, where they're slightly plugged in, and you can see that in this particular case we have it not fully seated, you'll see that it's slightly out there on the edge. We should have it fully seated, and both connections must be in a vertical position. Now, it may be hard depending upon if you have a power supply right here. You may need to look very closely, or in unique cases, if you have multiple mini stacked boards, you may need to remove the CPU board or other expansion boards to get down and check those connections. Again, this isn't common, but it can happen. Now, your ribbon cable will continue up and then plug into the top of the CPU. It's important to know that whenever you're plugging or unplugging these connections, they must be powered off. You cannot have the CPU powered on while it is being unplugged. So I'm powered it off, and I'm going to go ahead and just pull these connectors down, which will pop the connector out, and you can see that we have this connector. Now, this connector goes down to the very bottom, and if you want, you could actually pop these out like this, and that will allow you to easily gain better access to see down below. So make sure that your connectors are, again, fully seated in the vertical position, as you can see here. If you have any that are not, that means that there must not be a ribbon cable in there. At this point, the connections should be made properly into the controller, and the controller should be operational. So let's go ahead and take a look at the controller from the web interface to see if the controller can see these boards. All right, here we are. We are in the controller's web interface of the controller we just showed. So let's go ahead and take a look at that controller again. And we can see that this controller has one SPI and one long range. And we can see from the ribbon cable connectors, the SPI is on the very bottom one, so the lowest bottommost board is always going to be at the front connection, and the topmost board will be right here at the top. So this is long range. We do not have anything connected to number 2, middle one, and the number 3 will be an SPI board. So let's look at that in the web interface, because the controller should see the exact same thing. Now on the HinksPix, if we simply just go up and hover over the Port Config tab, we can see that this exactly matches the real world. We can see that in ports 1 through 16, which is the topmost connector, it sees the long range expansion board. We also see that 17 through 32, the middle connector, is not there, which is true. And then finally we have local SPI expansion ports on the last one. Now if you have a HinksPix Pro version 3, you'll see additional 49 through 80s down here. And in most cases of a simple controller, that will normally be empty. Now, if you were not to see these, for example, if you went in and you thought that this SPI board was there and you see the power is applied to it, everything looks okay, but it does not appear, there is some problem. Either the ribbon cable connector is not connected, there is a firmware problem, or some other major issue that's preventing the controller from seeing the SPI board. Again, most of the time this is going to be a ribbon cable problem. All right, so let's go ahead and switch over to our AlphaPix. Now, in this AlphaPix, what we have here is 3 boards, and let me just show you an example of what that looks like. So if we look here, we have a long-range differential, just like we do on the AlphaPix. In the topmost 1 through 16, we do not have anything on the middle connection of 17 through 32, and 33 through 48 will have an SPI board. So let's take a look at that. We see that. We can see that in port 1, which is 1 through 16, you can see 1 through 16 here, we do see that the board is present, and the AlphaPix Evolution does see this board. So this is okay. We see that the middle board is not there. Now you may see the configuration available, but there is no expansion board connected, so it is not visible. The third and bottommost board, we can see that it has a 16-port SPI, which is correct, and it is visible. So in both of these situations, what is connected does align correctly with what's showing in the web interface. Again, if we do not see a direct relationship between what's in the real physical world connected to the CPU and what's showing in the web interface, we should stop at that point. Something is wrong. All right, this concludes the second of the 3 video series. And at this point, we have troubleshot any problems that exist up until the controller's configuration. Now, it should be noted that this controller must be configured for your pixels to operate properly. So, if you are testing, you must have a proper configuration in the controller for operation. Now, in many cases, our controllers can be factory reset to output a default number of pixels to your outputs, usually either 50 to 100 will automatically be operational when you put the controller into test mode. And you do have test modes, as we showed in section 1 video. You can also implement some of these test modes directly from the web interface. Also, you can see there, and also within here we can do testing. So, see our third video if your problem has not been identified at this point.